6.6, the natural base E. E is used to estimate the ages of artifacts and to calculate interest that is compounded continuously. It is based on the compound interest formula, which you remember is A of t equals P times the quantity of 1 plus R over N to the NT. So what we have here, we have the compounding schedule. Annually, semi-annually, quarterly, monthly, daily, hourly, every minutely, every secondly. That is continuously. That means every second you're technically making money. Yes. And then we're going to fill in a chart. What this is talking about is if I have $1 and I'm investing it at 100% interest. So after 1 year, I have $2. All right? Semi-annually, that's 2. So I have 1 plus 1 half. Then I have, oh, that's still a, to the 2. What do I get for this answer? Actually, use your calculator. 2.25. Quarterly, how many times a year? 4. Monthly is 12. Daily, 365. Because I didn't. I didn't do weekly. How about hourly? What do I have to do? 365 times 60. Because there's 60. Oh, wait. Times by 24. You almost got me. This one's 8760. Okay, times this one for every minute. Times by 60 here. And I get 525600. Second, I take this and times it by.
Everything is talking about 60. Whoa. 31536.
That's how many seconds there are in a year. Okay, so I want you to find out what the value is for each one. All right, on this, the first one, I have 1 times 1 plus 1/4. And this one's going to be to the 4th power, which gets me 2.44. The next one, second enter, change that to a 12 to the 12th. And I get 2.61. Go in, change it now to 365. There was a faster way to do this.
Oh, you put it into a chart.
I get 2.71. Okay, that's what Malik just said. Do the next one. 525600 to the 525600. I get 2.72. Oh, wait, I skipped one.
Okay, she did.
What'd you get for hourly? 2.72. And what's secondly? What are you noticing? It's starting to become 2.72. If I put in the last one, let me just do it from the computer. The last one, 3153600. 3153600. It rounds to 2.72, but they're not exactly the same. This is very similar to pi, right? We just use 3.14. E is very similar to pi. The approximation for pi or for E is 2.72. All right? This is where E comes from. The reason why the letter E was picked, I have no idea. If I graph E of x, that is pretty much saying 2.72 to the x power. How is my graph going to look? You should know. Right, it's going to be something and then boom, like that. Yep. If I graph E. Now on the calculator, E, you know where the log's at now. Right below log, you see ln. Second ln is the E to the x. It's right below the log. Second ln, that gives you E to the x. When I graph, there's your graph. Just like Rochelle said. Find out what E to the 2 is, E to the 1/2, E to the -1. In the calculator, all I have to do. No, I'm not even going to graph. Second, ln 2. Close the parenthesis, enter. This one is about 7.39 to the 1/2. 1/2. Close the parenthesis, 1.65. And E to the -1. Enter. I get 0.37. I know I only went out hundredths. Questions? Oh yeah, I did say it's in the nearest thousand. Sorry. I could went second graph, but I have whole numbers. How could I get fractions? Second window, change the table set so it goes by 0.5. I could use the table just the same. Now I have 1/2, I have 2, and I have -1. This works fine. The continuous compounding formula. This means if we invest P dollars at a certain interest rate, it is compounded continuously. That means every second it's gaining money. The amount of money A of the investment at any given time is A equals P E to the RT, PERT. Compare a $1,000 investment with an annual rate of 6.5% for 8 years that is compounded annually and one that is compounded continuously. We will have two different formulas here. The first one for compounded annually is A equals P times 1 plus R to the T. For one that's compounded continuously is A equals P times E to the RT. I want you to find out how much money you have after 8 years for both. For the first one, A equals, how much money? 1,000. 1 plus, what's my rate? 0.065. What's my time? My time is 8 years. $1,000 times 1.065 to the 8th. I added the 1 and the 0.065. $1,654. No, it's going to be 55. That's how much money you have after 8 years. The other way, we have 1,000 times e to the 0.065 times 8. 1,000 second ln 0.065 times by 8, close the parenthesis, enter. $1,682.03. I'm just moving the calculator. So compounded continuously, you make about $30 more. It's not a big difference, even though some people think if I took the money and I made interest every single second, you're going to make a ton of money. It doesn't work that way. Because you got to think, after a second, you're making fractions of a penny. And then eventually it adds up. Right. The natural logarithm function. If I were to find log base e of x, that is the same thing as ln of x. If I were to take log base e just means ln, the natural logarithm. Well, we said the other day, I think it was, log and 10 to the x are opposites of one another. E and ln are opposites of one another. ln, natural logarithm. I don't know. No clue. So we're going to find ln of 2, ln of 1/2, ln of -1. All I do is hit the ln, which is next to the 4, 2, and I get, I'll do it correctly this time, 0.693. ln of half negative 0.069. I have decimal in the wrong spot. 0.693. And ln of -1. Why is this no solution? Really, what ln means is you're taking the log base e of -1. You can't take the log of a negative number. The only thing you can take a negative number of is 10 to the x and e to the x. Logs and ln's cannot have negatives. All right? This is the types of problems we're going to be doing. How long does it take our $1,000 investment to double at the interest rate of 6.5% compounded continuously? Still the same formula. A equals P e to R to the T. My amount is still 1,000. P, oops, sorry. That's my P. E means E. My rate is still 0.065. I want to find out the time. Now I want my amount to double. So it's 2,000. In other words, 2 equals e to the 0.065 t. Are we okay up to now? What did we do in the past if we had exponentials? We took logarithms because they're opposites, right? What's the opposite of an e? ln. So I take the ln of 2 equals the ln of e to the 0.065 t. Whatever I do to one side, I can do to the other. Now, if I go in the calculator and put ln e to the 0.065, I get just the exponent. So I have ln of 2 equals 0.065 t. T's not an exponent anymore. It's now brought down. Just like on yesterday's homework, it was brought down with it when we took the logs. Yes, ln gets rid of an e. An e gets rid of an ln. Now I need to divide, so I have ln of 2 divided by 0.065. ln of 2 divided by 0.065. It takes about 10.7 years. It will take about 10.7 years for my money to double. It is a lot, but not bad. If you buy a savings bond, it takes around 15 years. Correct. Questions? And that's it for this section.